Hey guys, and welcome to the tutorial. My name is Umar and my group mates are Elena, Shukri, and Pulad. In this video tutorial, we're going to be talking about a simple Android application that we wrote. We will be using Xamarin framework that enables us to create Android apps using C#. If you're experiencing problems with installing or running Xamarin, consider watching the tutorial videos that Pulad made, or search for the error online. The tutorials that Pulad made are sent to the group members through email, and they're also uploaded to the shared folders. We have sent you the project's zip file with this video. During this tutorial, we go over the code that we wrote and try to explain it. Our application is a simple rock, paper, scissors game. Extract the project's zip file and open the solution. We have organized each part into a region. We are going to open them in order to explain those parts. Here, you see an overview of the topics that we're going to cover. First, we quickly create a simple layout and then implement the app's functionality. After that will come the parts for activity lifecycle and intents. Next thing we'll be enhancing the layout by using two more attributes. And finally, the assignments. We hope you will follow this tutorial and will do the assignments. The solution to the assignments will be posted on the group next Tuesday, so if you manage to do any of those assignments, please send us your code as an email. Alright, let's get started. The first part will be presented by Elena.
Hi everybody! Today I'm going to talk about how layouts work in an Android application. Layouts control the visual structure of elements on the screen. You can see some examples of common layouts here. In our game, we are going to use some linear layouts together. Linear layouts organize children in a horizontal or vertical row. This is how our app's design will look by the end of this tutorial. We have a bunch of images and buttons on the screen. These three image buttons are put together using a linear layout with vertical orientation. The blue boxes here represent the horizontal linear layouts. These layouts are also nested with other layouts, shown by the red boxes. And then finally everything is nested within a vertical layout, shown by the yellow box. Now I will open Visual Studio to begin creating the layout. In the Resources folder, go into the Layout folder and open the main layout. We already have the layout finished, but for the tutorial we will do it again. Just like HTML, the visual structure of a layout in Android is controlled by an XML-based language. Let's take a look at the source code. Let's delete everything from line 7 to line 108. Now we are left with a single linear layout with vertical orientation. I'll pin this toolbox here in the design mode for easy access. In the start, we only have the outer vertical layout, which was the yellow box. Now we will place three horizontal layouts within the outer vertical layout. We will also place two more horizontal layouts in the first two horizontal layouts from the top. Make sure to drop them carefully within the box. We can also drag and drop view elements the same way as layouts. The fill box designates that it will be placed within the container. In the middle horizontal layout, we have a nested vertical layout with three image buttons. The button horizontal layout contains two buttons. Each view element has a type such a button or text view. They also have a unique ID. We assign them IDs so we can work with them later in the code. We also will be adding the images wherever is needed. We have added some images to the drawable folder. I go to the image views first. They have an ID and a source attribute. Assign the ID to IV for the type image view and then player. And set the image using the src source attribute. I do the same for the rest of the view elements on the layout. Now we have a layout to show to the user, so Shukri is going to go over the app's logic.
In this part, I'm going to explain the logic behind the game. First, let's have a look at the game in the emulator. When the user clicks on one of the image buttons, the game is started and the CPU makes its own choice. The image for CPU's choice is changed and the winner's score is incremented. If the result was a draw, a toss message is shown. I expand region 0, class fields, declaration. Here, the variables I need to work with are declared as class fields. They are in class scope, so will be accessible in every method of this activity. Before going over the next region, let's have a quick look at the slides. The XML code on the right side is just an example of a layout that contains a button with ID be reset. What we have on the left side is the code for that activity. We can use the method findViewById to create an object from the element on the layout. We need to provide the type of the element and its unique ID as an argument. Xamarin framework takes care of constructing this resource.id class every time we edit and save our layout. Now the code in this part should make sense. You may also find this method similar to findElementById function in JavaScript. Having all the variables initialized, I go to the region play event handlers. I simply have changed the play method to the click event handlers of 3 image buttons. Now I go to the region for play method. Since the play method is supposed to handle the click event, it must accept 2 parameters. First one is of type object, which represents the center or the image button that user clicked on. The other parameter is for the event arguments. In the method, we use random number generator to have random choice for CPU. Then we check for the winner inside the switch statements. For example, if CPU's choice was rock, we show it to the user by changing the CPU's choice image to rock. After that, we simply check which image button user clicked on. In the case of draw, we show a toast message to the user. If we had a winner, we increment the winner score by 1 and change the text view in the layout. The logic for cases 1 and 2, paper and scissors respectively, are similar to the case 0. Now go ahead and open the region for lambda expressions. Lambda expressions are just a shorthand way for writing anonymous methods. Whenever the button reset is clicked, all the score counter's text views are reset to 0. As I mentioned before, every method that handles click event must receive 2 parameters. I put those 2 inside round brackets. The close button has only one task, calling the method finish to close the app. Since the compiler expects 2 parameters of type object and even args, I can just write their names. Now, this is the end of my part, and Omar is going to continue by talking about the lifecycle of an activity.
In this section, I'll cover the activity lifecycle in Android. Android OS calls some specific methods from an activity when the activity goes in different states. We can put some code in those methods to be processed. The methods are called lifecycle methods. When the user clicks on an application, the app starts from the first activity, the launcher activity. Android OS calls the activity's onCreate method. OnCreate is the only method that is mandatory for every single activity. We can use it to initialize variables and set display layout. Then come the onStart and onResume methods. When the onResume is called, activity is visible and has a focus, and the user can interact with the app. OnPause method is executed when the activity is partially visible. For example, a dialog box for entering a date can cover a part of the activity. If the user navigates away from our app to another app and our activity becomes completely covered, the onPause and then onStop methods will be called. In this state, the app is still alive, but it is not visible. After that, when the user opens up our app again, the methods onRestart, onStart, and onResume are called. We can write some code in onRestart method to allocate resources again. And lastly, we have onDestroy. The app is shut down when the user hits back button from the launcher activity, Android OS needs resources such as memory, or the device is rotated. Back to the code, expand the region 3 activity lifecycle. Here I have overwritten 3 methods, onStart, onStop, and onDestroy. This will help to understand the lifecycle of an activity. Just like any other lifecycle method, I start by calling the base classes method and then simply showing a toast message that says the name of the method. Toast messages are going to be shown whenever these methods are called. So let's launch the app to see the lifecycle methods in action. The onStart was called at the start of the activity as expected. I press the home button and onStop is going to be called now. I encourage you to override other lifecycle methods such as onPause. This will help you better understand the order of these method calls. Now the app is in running state, and I'm going to rotate the screen by pressing the keys Ctrl and F11. As the toast messages told us, onStop, onDestroy, and again onStart were called one after the other, so the activity was initialized again. This means that the layout was destroyed and then recreated. As a result, the information that we had, such as the scores, is now lost. There are 2 other lifecycle methods that can address this issue. We use those methods to maintain the state of the application during the lifecycle of an activity. With the use of the method onSaveInstantState, we can save some data that we want to maintain. The method is called just before onPause. On the other side, we get all the data that we saved in the method onRestoreInstantState. Let's expand the